In this video, we want to do some questions about geometric series. Find the value of x such that sigma n from 0 to infinity of e to the nx is 2025. Let us start with this sigma here. If we plug in 0 for n in the general term of this sigma, then we have e to the power of 0x. We plug in 0 for n, and the first term of the sigma, first term of the series, is e to the 0x, which is e to the 0, and e to the 0 is 1. So the first term of this series is 1. What is the next term? If you plug in 1 for n, the next term is e to the 1x or e to the x. What is the next term? E to the 2x, e to the 3x, and it goes for infinity. We want to find the value of x such that this sum in the left equals 2025. Now look at these terms here. If you pay attention, they form a geometric series. But why this is a geometric series? Let me remind you the general form of a geometric series. A geometric series is a series in the form of a r to the power of n minus 1, which if we open this, we have ar to the 2, and so on. What do you see here? We have a first term that is multiplied by a constant ratio. If we multiply a by r, we have ar. Then we have ar to the 2, ar to the 3, and so on. So, geometric series is a series that has a fixed ratio between the terms. By multiplying each term by that ratio, we can get the next term. And if you pay attention here, if we multiply the first term by e to the x, then we have the next term. By multiplying this by e to the x, we have the next term. By multiplying this term by e to the x, then we have the next term. Because, for example, e to the 2x times by e to the x is e to the 3x. So this is a geometric series, which in this geometric series, the ratio of the series is e to the x. And if you pay attention, the first term of the series, first term is 1. Now let me remind you this formula for sum of a geometric series. When we have a series in the form of sigma ar to the n minus 1, n from 1 to infinity, the sum of this series, if it is convergent, the sum of the series is a over 1 minus ratio, which a is the first term and r is the ratio. This is the formula for sum of a series, sum of a geometric series. And attention, this formula is valid only when the series is convergent. When a series is convergent, when the absolute of the ratio is less than 1. But I highly recommend you not to memorize this formula for sum of a geometric series. So what we have to learn for geometric series, sum of a geometric series? The better way to memorize the sum of geometric series is this formula. First term over 1 minus ratio. This formula is much better than this formula, a over 1 minus ratio. Maybe you will think by yourself, okay, but this is the same formula. Yes, it seems the same, but it's not exactly the same. Because sometimes a is not exactly the first term. So I highly recommend you to memorize this formula for sum of a geometric series. Sum of geometric series is first term, which in this case is 1, over 1 minus ratio, which is e to the x. Now that we remember the formula for sum of a geometric series, let's finish this question. So, what is this sum? This sum is first term, remember, first term, what is first term? 1. Over 1 minus ratio. What is the ratio of this geometric series? E to the x. Ratio is e to the x. Because e to the x is the number that is multiplied by each term, and we have the next term. That is the ratio. And this should be equal to 2025. Now we have to solve this equation. For solving this equation, we can give a 1 to the denominator of this, and then we can do a cross multiplication. By doing a cross multiplication here, we have, suppose we have a 1 here, 1 times 1 is 1, and in the other side we have 2025 times 1 minus e to the x. We multiply denominator by numerator, denominator by numerator. Now we have to solve this equation. Multiply the 2025 in the bracket, then we have 1 equals 2025 times 1 minus 2025 times e to the x minus 2025 e to the x. To find x, we move this to the left and we move 1 to the right. So from this we have 2025 e to the x equals 2025 minus 1, 1 goes to the other side, 2024. Now, if we divide both sides by 2025, then we have e to the x is 2024 over 2025. And for solving this, probably you know that when we have e to the x equals something, x is ln of that thing. So x is ln of 2024 over 2025. If you want to learn the basic things about geometric series and you want to get more familiar with geometric series and its sum, watch my video about geometric series. Now look at this example. Find the value of a if sigma n from 1 to infinity of 1 plus a to the power of negative n is 3. Again, it should be clear for you that this is a geometric series, because if you pay attention, we have a constant raised to the n. It is negative n, but you can suppose this negative for the base, so you have an expression raised to the n, and this means that it is a geometric series. But if you want to clear for you that this is really a geometric series, you can start writing the terms of a series, and then you have to look for a constant ratio. If you plug in 1 for n, what is the first term of this series? The first term of this series is 1 plus a to the negative 1. So the first term of this series is 1 plus a to the negative 1, which you can write it as 1 over 1 plus a. It is up to you to write it this form or this form. Maybe you prefer the fraction form because you don't like the power to be negative. So when we plug in 1 for n, the first term of this series is 1 over 1 plus a. What is the next term? 1 over 1 plus a to the 2. Because if you plug in 2 for n, then we have 1 plus a to the negative 2. And this is the second term. What is the third term? 1 over 1 plus a to the 3, and so on. And this sum should be 3. Now if you notice, this is our first term, and if you pay attention, we can see that a fixed ratio is multiplied by this, and then we have this. A fixed term is multiplied by this, and then we have that term, the third term. If you multiply that fixed ratio by this, then we can get the next term, and so on. So this is a geometric series. But what is that ratio that is multiplied by this, and then we have this? That ratio, you have to look for something that 1 over 1 plus a is multiplied by that term, and then we have 1 over 1 plus a to the 2. That ratio that we are looking for is 1 over 1 plus a, because 1 times 1 is 1. Denominator times denominator is this. And If you multiply this term by this ratio, you can get the third term and so on. So, in this geometric series, what is the first term? The first term is 1 over 1 plus a. What is the ratio? The ratio is also 1 over 1 plus a. Now if you remember the formula that I told you to memorize, the first term over 1 minus ratio is the sum of a geometric series. So it's sum of this geometric series is first term, which is this, over 1 minus ratio, and it should be equal to 3. If we use this formula, first term is 1 over 1 plus a, all over 1 minus ratio 1 minus 1 over 1 plus a, and this should be equal to 3. Now we have to solve this equation for finding a. To solve this equation for a, you have different ways. One way for solving this equation is to do a common denominator here, then to divide numerator by denominator. But is there a better way to solve this equation? Yes. Please pay attention to the technique that I'm going to use to solve this equation. And that technique is better than doing common denominator. If you look at the numerator and denominator, you notice that in numerator and denominator we have fractions. And both of these fractions have this denominator, 1 plus a. If we can get rid of this denominator, then easily we can solve this equation. So for that reason, I am going to multiply the numerator and denominator at the same time by 1 plus a. Why we multiply the numerator and denominator by this? Because we want to get rid of the denominators, which is 1 plus a. And attention, because we multiply numerator by something, we have to multiply denominator by that thing at the same time, because we don't want to change the equation. So, for solving the equation, we multiply numerator and denominator by 1 plus a. What happens if we do this? By multiplying the numerator by this, 1 plus a with 1 plus a cancels, and only we have a 1 in numerator. So from numerator we have only a 1 all over 1 plus a times 1 is 1 plus a minus 1 plus a times by this fraction. This goes with this and we have minus 1, so minus 1, and it equals 3. As you can see, my technique for solving this equation is much better than doing common denominator and dividing numerator by denominator and so on. Simplify this denominator. 1 plus a minus 1 is a. 1 minus 1 is 0, 1 over a. So far we have 1 over a is 3. If we do a cross multiplication, 3a is 1, and so a is 1/3. The question was find the value of a such that this sigma is equal to 3. So a is 1/3. Now look at this example. Express each number as the ratio of two integers. 0.6 bar, which means that 0.6666666 forever. We want to write this number as the ratio of two integers. For example, if we want to write this number as a number over another number, two integers, which we will see that this number is basically 2 over 3. But how we can find the answer? We want to use geometric series to answer this question. Pay attention that what is 0.66666 forever basically? If you attention, this number is basically 0.6 plus 0.06 plus 0.006 plus 0.0006 and so on forever. Because, for example, the sum of these two is 0.66. The sum of all of these three is 0.666. The sum of these 4 terms is 0.6666. And if we continue this forever, then exactly we have this. So now it should be clear for you that this decimal number is basically 0.6 plus 0.06 and so on. Now attention, 0.6 can be written as 6 over 10. You can keep it this form, but I prefer to write it in fraction form. 0.6 is 6 over 10. 0.06 is 6 over 100. The next one is 6 over 1000. 6 over 10,000 and so on. Now if we look at these terms, they seem to be a geometric series because we have a first term that is multiplied by a fixed ratio and we have the next terms. What is the ratio of this geometric series? What number is multiplied by 6 over 10 that then we have 6 over 100? The ratio is 1 over 10 because 6 times 1 is 6, 10 times 10 is 100. And if you multiply 6 over 100 again by 1 over 10, then you have 6 over 1000, the next term, and so on. So this means that this sum here is a geometric series. And we know that the sum of a geometric series, if you remember the formula that I told you to memorize, the formula is this. First term over 1 minus ratio. What is the first term here? The first term is 6 over 10. All over 1 minus ratio. Ratio is 1 over 10. Let's simplify this. In numerator we have 6 over 10. 1 minus 1 over 10 is 9 over 10. And if you simplify this, 6 over 10 divide by 9 over 10. This is 6 over 10 times by 10 over 9. 10 with 10 cancels, 6 with 3 simplifies, 2 over 3. So the answer is 2 over 3. The other way that you can simplify this fraction here, let me show you a trick that you can simplify this a little easier. When you divide a fraction by another fraction, if denominators are the same, you can cancel them. And then the answer is numerator over denominator, 6 over 9. You don't need to really divide. So, when you divide a fraction, like this example, by another fraction, if denominators are the same, cancel them. If numerators are the same, you can cancel numerator with numerator, denominator with denominator. So, by the way, this is another story. We don't want to talk about simplifying fractions. Our focus is on geometric series. So, this sum is 6 over 9, which is 2 over 3. If right now you use a calculator and you divide 2 by 3, you would see that the calculator would give you this number, 0.6666 forever. Now look at this example, 0.46 bar, which is 0.46, 46, 46, 46, repeating forever. This number can be written as 0.46 plus 0.2046 plus 0.4046 and so on. I prefer to write it as decimal, as fraction, 46 over 100 plus 46 over 10,000, 46 over 1 million and so on. What is the sum? First term, which is 46 over 100, all over 1 minus ratio. And what is ratio? Can you find the ratio here? 46 over 100 is multiplied by some number, and then we have this term. What is that number? What is that ratio? That ratio is 1 over 100. 46 times 1 is 46. 100 times 100 is 10,000. So the ratio is 1 over 100. So first term all over 1 minus ratio. And ratio is 1 over 100. So this equals to 46 over 100. 1 minus 1 over 100, it should be clear for you that if you do a common denominator, it is 99 over 100. because this is 100 over 100 minus 1 over 100 is 99 over 100. Now remember the trick that I told you can use. Cancel this with this, and the answer is 46 over 99. So this decimal number can be shown in the form of ratio of two integers, ratio of 46 over 99. I hope by watching this video now you are more familiar with geometric series, and now you can solve more advanced questions about geometric series. If this video was helpful for you, please subscribe to my channel and see you in the next videos.